the countdown is on for NASA's next groundbreaking mission, set to launch from Titusville, Florida. This mission promises to deepen our understanding of the Sun and its influence on Earth's space environment. But here's where it gets controversial. How much can we really predict about solar storms, and are we prepared for their potential impact? Introducing the IMAP spacecraft, NASA's latest venture into studying the Sun's powerful solar wind and its effects on our planet. Scheduled to lift off no earlier than late September from Kennedy Space Center's Pad 39A aboard a SpaceX Falcon 9 rocket, IMAP is poised to revolutionize space weather forecasting. IMAP arrived at the Astrotech facility in Titusville back in May, where it has been undergoing rigorous testing and preparation. Now fully fueled and in the final stages before being enclosed in the SpaceX payload fairing, the spacecraft is almost ready for its journey. By mid-September, IMAP will be transported to meet its Falcon 9 rocket, with the launch pad awaiting its arrival just days before liftoff. IMAP's mission is to study the solar wind and energetic ions streaming out from the Sun into the heliosphere, explained Kieran Hegarty, IMAP program manager, in an interview with Florida Today. To put it simply, IMAP will monitor the stream of charged particles emitted by the Sun, often called space weather, which can have significant effects on Earth's technological systems. One of the mission's key objectives is to explore the heliosphere, a vast bubble created by the solar wind that envelops our entire solar system. Understanding the heliosphere's boundaries and behavior is crucial because it acts as a shield against cosmic radiation. IMAP is equipped with 10 advanced scientific instruments developed through a collaboration of 25 international partners. The spacecraft's design includes 6 bays housing 12 sensor instruments, plus a large sensor mounted on top. Despite its relatively compact size, standing just 3 feet tall and 8 feet wide, IMAP weighs nearly 2,000 pounds, reflecting the complexity and sophistication of its equipment. After launch, IMAP will embark on a 108-day journey to the Earth-Sun Lagrange Point 1, L1, located about 1 million miles from Earth. This unique spot allows the spacecraft to orbit the Sun in sync with Earth, providing a stable vantage point for continuous solar observation. The data IMAP collects will be invaluable for predicting space weather events. Solar storms can disrupt satellites, endanger astronauts, and interfere with communication and navigation systems. IMAP's ability to offer up to 30 minutes of advance warning before harmful solar radiation reaches Earth could be a game-changer, giving operators critical time to protect vulnerable technology. But IMAP won't be making this journey alone. 2 other spacecraft are set to launch alongside it: NOAA's SWIFT FOL-1 and NASA's Carruthers Geocorona Observatory. In a nearby cleanroom at Astrotech, preparations are underway for these companion missions. The Carruthers Geocorona Observatory will focus on mapping Earth's exosphere, the outermost layer of our atmosphere, by detecting ultraviolet light emitted from this region, known as the geocorona. This layer extends surprisingly far. During the Apollo 16 mission, Dr. George Carruthers discovered it reaches as far as the Moon, but its full extent remains a mystery. Meanwhile, NOAA's SWFO-L1 spacecraft will monitor space weather by observing charged particles streaming from the Sun, complementing IMAP's measurements and enhancing our ability to forecast solar storms. Robert Curbeam, CEO and President of Astrotech Space Operations, emphasized the importance of this launch in a recent press release. Astrotech is proud to support this critical mission rollout, marking our 551st spacecraft process to date. We eagerly anticipate the successful launch of these vital Sun-focused missions. As these 3 spacecraft prepare to head to Kennedy Space Center's Pad 39A, space enthusiasts along Florida's Space Coast can look forward to an exciting late September launch window. But here's the part most people miss. While these missions promise unprecedented insights and warnings, the question remains: are we truly ready to act on this information when the next major solar storm hits? How much should we invest in protecting our infrastructure versus relying on early warnings? What do you think? Are these missions enough to safeguard our technology-dependent world, or is there more we should be doing? Share your thoughts and join the conversation below. Brooke Edwards is a space reporter for Florida Today. You can reach her at bedwards@floridatoday.com or follow her on X @BrookeOfStars.